Hi, and welcome to this course, Combining and Visualizing Data Using Generative AI. My name is Janani Ravi, and I'll be your instructor for this course. Combining data involves bringing data together from multiple sources for analysis and exploration. This is a key data manipulation technique and well supported in the Pandas library. Exploratory data analysis involves data visualization to understand the relationships that exist in your data. Matplotlib, Seaborn, and Plotly are essential tools for data visualization. Prompt engineering can help you pick the right visualization for viewing and understanding relationships between variables and can also generate code for these visuals. You'll start this course by combining data in data frames using vertical stacking and horizontally based on a common column. You'll learn techniques to join data frames using different constructs such as the inner join, left and right joins, and the full outer join. Next, you'll delve into time series analysis and visualization. Time series involves values like stock prices or supermarket sales recorded over time at regular intervals. You'll use prompt engineering to help you visualize your time series data to identify trends and patterns. Finally, you'll explore data visualization in Python. You'll begin by crafting univariate visualizations that display information about a single variable. You'll see that tools such as ChatGPT and Bard can help you pick the right visualization for different use cases. You will then explore bivariate visuals, which showcase the relationship between two variables. You'll also use Plotly to generate interactive visualizations, which are more user friendly and intuitive. In conclusion, this course will equip you with a comprehensive understanding of merging, analyzing, and visualizing data, harnessing the power of prompting to help make your data science tasks easier. So far, in all of the data manipulation and analysis that we've performed, our entire dataset has been in a single data frame. But what if our data is spread across multiple source files and we load these into different data frames? How do we bring together our data for analysis? That's what we'll look at in this demo. Here on my Jupyter Notebook server, I have my home page open and we'll be working in this Python notebook called Combining and Joining Data. Now I have the datasets folder here. I'm going to click through to this folder and you'll see all of the datasets that we'll be working with. So there are many different files because these are all the different source files which contain our data. And we'll bring this data together using a variety of combining and merging techniques. Now, there you've seen the data that we're working with. Let's head over to our Jupyter notebook and import pandas as PD. The first bit of data that I'm going to read into a data frame is US sales data. This is data that I've taken from the AWS SaaS sales dataset, except that I've split it up into data for different countries. US sales data contains sales of all AWS SaaS products to the United States. Notice that the country column says United States. Let's see how many records we have for the US. US sales.shape tells me 2001 and 12 columns. Just as AWS products were sold to the US, they were sold to Canada as well. I'm going to read in the Canada sales information into a separate data frame called Canada sales. Notice that the country column is always Canada. These are all products sold to that particular country. Let's take a look at how many records we have in this data frame, and sales to Canada comprise of 506 records. Sales of AWS products to France are in a separate source. This is a separate CSV file called francesalesdata.csv, and I read that into a separate data frame. Notice the country column, it's always set to France. Let's see how many records we have in this data frame. We have a total of 587 records. Now, let's say you want to perform some analysis across segments and customers and products across records for all three countries. You'll want to bring together all of your data into a single data frame. Let's turn to ChatGPT for help and ask it how we can actually accomplish this. I start my conversation in a brand new session. I have the sales data for different countries in separate pandas data frames. Is there a way to combine these together into a single data frame? I haven't specified additional details on how I want these data frames to be combined. ChatGPT tells me there are multiple ways to combine data. You can use the pd.concat function, and if you want to stack data frames vertically on top of one another, you use pd.concat with axis equal to 0. This will stack your data frames vertically. To combine data frames horizontally side by side, we use pd.concat with axis equal to 1. There are other techniques to combine data frames. This includes pd.merge. We'll look at that in a bit, so let's just ignore that for now. And there is also the pd.dataframe.append function, which allows you to append one data frame to another. I think what we need here is to be able to stack our data frames one on top of another. So I'm going to use pd.concat. I haven't specified the axis property, but the default value for axis is axis equal to 0. I pass in US sales and Canada sales to pd.concat, and the data in these two data frames will be stacked one on top of another. Here is my combined DF. The records at the head contain all records for America, and if you look at the tail of this data frame, you'll see all of the records are from Canada. There is an important implicit assumption that I've made here while combining this data. I've assumed that the names of the columns and the order and types of the columns in the two data frames are identical, and that's why this vertical stacking just works without a hitch. If you now look at the shape of the combined data frame, it should contain records from the US and Canada, a total of 2507 records, 506 from Canada, 2001 from the US. Now let's say I have this combined data frame and I want to look up the record at index position 400, and I use the lock indexer function for this. And when I say row 400, I'm expecting one row, but I get two. One for the United States and another for Canada. This is kind of strange. I'm not really sure what's going on here, but I do another lookup using the lock indexer. And I look up records at indices 230, 120, and 567. I've just picked these values completely at random. And here is something strange and weird. There are two records for index values 230 and 120, but just one record for the index value 567. Now I'm really confused at this point in time, so I turn to ChatGPT for some debugging help. And I try to put down as much context as possible. I use this pd.concat function to concatenate multiple data frames, but when I try to access the records at specific indexes using this code, I got multiple records for index 230 and 120 and just one record for 567. Why do I have multiple records for the same index? And the response from ChatGPT really helped clarify why this happened. If you have multiple records for the same index, it's likely because the original data frames you're concatenating had duplicate index values. And that's true. Both the US sales and Canada sales would have the same index value starting from 0. The data frame that we get from pd.concat inherits the index from the original data frames. The duplicate values from the original data frames are now present in our result. How do we fix this? Using this code that you see here. We perform the concat and then call reset index drop equal to true. So this is what I'm going to try in my Jupyter notebook. I use pd.concat to concatenate US sales and Canada sales and then call reset index drop equal to true. And here is a sample of my records. Let's see if we have multiple index values this time around. I look up the same index values 230, 120 and 567, and this time around I have exactly one record corresponding to each index. Reset the index values of the combined data frame to start from 0 and go up to the last index. The index is no longer inherited from the original data frame. Now let's get the data for France into this data frame as well. Great, that worked. That is the resetting of the index. I now want to add data for France to the same combined DF. I don't want to create a new data frame. How do I do this? Remember, pd.concat creates a new data frame. Turns out I can still use pd.concat and take the original combined DF, combine it with France sales, and assign the result to combined DF once again. This is a neat little trick. Let's try exactly this in our Jupyter notebook. Notice I've made one slight tweak. Instead of using reset index drop equal to true, I use ignore index set to true, which means the index values from the original data frames will be ignored and the new data frame will start at index 0. Let me rerun the data frame to confirm that it contains records from the Canada, United States, and France. It took a few tries, but there you see it. We have records from all three countries combined together into a single data frame. Now let's read in some more sales data. Sales data for Germany is in the Germany sales data.csv file, and I'm going to read that in. This is what the data frame looks like. Let's read in the sales data for Italy as well, present in the Italy sales data.csv file. As I'm inspecting the data, I realize that the data frames are not exactly the same. Notice that the third column for Italy is country, but the third column for Germany is discount. The second to last column for Germany is quantity. The second to last column for Italy is discount. So clearly we have the same columns, and a quick glance shows me this is the case. The columns in the two data frames have the same names, but they have different orders. Now let's see if combining these two data frames using pd.concat will work. pd.concat Germany sales, Italy sales, ignore index is equal to true. And if you look at the combined data frame, things seem to be quite okay. The discount column seems to have the right values, as does the country column. It's pretty clear that as long as the column names match, even if the columns are in a different order in the two data frames, Pandas is able to combine them correctly. Now let's read in some more data. I have the sales records for India in the India sales data.csv file, and I'll read that into one data frame called India sales. I have the sales record for China. This is in a separate CSV file, China sales data, and I read that into the China sales data frame. I'm going to give you a little hint about what's going to happen next. Take a look at the column headers in these two data frames. Do you notice any difference, or do you think they're exactly the same? Well, if you said they're different, you're absolutely right. Notice that the India sales data frame has the company column, whereas the China sales data frame, the column is called customer. India sales has the type column after industry, whereas China sales has the segment column after industry. They contain the same information though. Now, maybe you didn't notice this difference. It's kind of hard to see if you're quickly processing data. And then you went ahead and concatenated these two data frames using pd.concat. And you get a combined data frame as a result, and things seem to look okay, but then suddenly you realize that there are some issues. You might then observe that there are some columns with a large number of NaN values. For example, company has a bunch of NaNs, type has a bunch of NaNs, customer and segment also have NaN values, and you're kind of wondering why this is the case. And if you haven't figured this out, you can always turn to ChatGPT for help. For debugging, make sure you give as much context as possible. I tried to use pd.concat to combine two pandas data frames, but I get NaN values in some columns. I don't think the original data contains any NaNs. Do you know why the combined data contains NaNs? Let's see what ChatGPT has to say. And its diagnosis is quite correct. It's possible that the original data frames have columns, different names, or different orders of columns. We know that pandas can deal with columns that have different orders. We've already seen an example of that. But columns with different names, that's our current issue. Let's get ChatGPT to be more specific by asking a follow-up question. I don't think the order of the columns are different, and in any case, Pandas concat is able to deal with columns in different orders. What else do you think could be wrong? And this follow-up question did not really help ChatGPT pinpoint the answer. It starts suggesting all kinds of other problems that you could have: index mismatch, data alignment, data types, and so on. All of these could be possible issues, but we know what our issue is. Our column names do not match. This is what ChatGPT had originally suggested. The fix for that is to rename the columns in one of the tables to match the other. So I rename the columns in the India sales table so that company is called customer and type is called segment. With this in place rename, the India sales data frame now contains column names that exactly match the China sales data frame. And now, if we perform the PD concat, things will work out just fine and there won't be additional NaN values in any of the columns. Now, let's say you're looking at code written by someone else in your team and you come across the pd.concat function with an additional keys argument. Here I concatenate India sales and China sales and I specify keys equal to India, China. The resulting data frame seems to have an additional index containing values either India or China, but you're not really sure what exactly this code does. You can turn to ChatGPT for an explanation. I've seen code like this in my code base while concatenating sales data of two countries. What does this keys argument do and how does it help? And I've pasted in an example of using keys. It turns out that the keys argument is used to create a hierarchical or a multi-level index for the concatenated data frame. This allows us to distinguish what data came from each of the original data frames. Having this multi-level index can help if you want to be able to identify which rows of the data belong to India and which belong to China. It can help with grouping and aggregation, finding subsets of data, and visualization. And that's why it's a useful property to add in while concatenating data frames. If you have a multi-level index, you can look up records for India by writing code such as this one. Use the lock indexer, look up India, and this will give you the records for India. Similarly, you can use the lock indexing function, look up China, and this will give you access to all of the records that came from the China sales data frame. So far, we've seen how we can combine data frames together by vertically stacking them using the pd.concat command. In this demo, we'll see how we can merge or combine or join data frames based on values in a common column. Now, we'll work with a different set of data for this demo, and I'm going to load this data into different data frames. All of this data that I'm going to be using now is from this data set originally. I've simply sliced and diced this data so that it's suitable for the join operations that we're going to study. This is the HR dataset available at this URL here on Kaggle. The first bit of data that I'm going to load in will contain personal details of employees in a particular organization. This is in the employee personal details.csv file. For every employee, we have a unique employee ID, then we have the name, the sex or gender of the employee, the marital description, that is the marital status, and the date of birth for the employee. This is the personal information. Along with personal details, we also have the professional details for an employee in the employee professional details.csv file, and I read that into a separate data frame called employee professional details. We have the same employee ID uniquely identifying employees, and then we have salary, position, department ID, and manager ID information. I should tell you upfront that for certain employees, we have their professional details but not their personal details. And for other employees, we have their personal details but not their professional details. So, for some employees, the information is incomplete. Let's say you now want to combine or merge this data. You want the professional and personal details of employees to be in a single data frame. Let's ask Bart for help with this. I have two pandas data frames, employee personal details and employee professional details. How do I combine this information into one data frame? Employees can be identified by a unique employee ID. So the employee ID is unique to an employee, and this is what we'll use to match the personal and professional details. Let's see what Bard has to say. Bard says that you can use the merge function to perform this operation. It takes in two data frames and returns a new data frame that contains the merged data. And you use the on parameter to specify what column you want the two data frames to merge on. And here below is an example of how you can use pd.merge. pd.merge takes in the two data frames, employee personal details, employee professional details. And if you scroll over to the right, you can see that we want to merge on the common column, that is the employee ID. pd.merge is not the only way to merge these two data frames. I asked Bard, isn't there a merge function on the data frame itself? Could we use that? And Bard says that yes, certainly we can. Instead of using pd.merge, you can invoke the merge function on one data frame to merge it with another data frame based on a common column. You can see the code here, df1.merge df2 on empid. Let's try this with our personal and professional details. I'm merging employee personal details with employee professional details on the emp ID column. I haven't specified anything else about how I want the merge to be performed. Let's take a look at the result here. So for every employee ID here in the result data frame, we now have the personal as well as the professional details. Let's dig in a little further. Let's take a look at the number of records in the employee personal details data frame. We had 302 records there. Now let's see how many records we have in the employee professional details data frame. and this contains 300 records. Now, how many records does this merge data frame contain? Employee details.shape will tell us this contains just 293 records. The employee details contains fewer records than either of the original data frames that we merged, and this is kind of confusing to me initially, so I turned to Bard for help. This is a follow-up question, so I have less context. I perform this operation where this refers to the operation Bard has suggested, and the combined result seems to have fewer rows than either of the original data frames. Do you know why? And Bard gives me some very clear explanations here. That's because when we merge the data frame, the operation that was performed was the inner join. If you're familiar with SQL, you know what the inner join is. When you merge using the inner join operation, only records that have matching values on either of the original data frames will be present in the final result. So if you have only the employee's personal details or only the employee's professional details, that record will not be present in the final merge result. Other reasons for having fewer records in the result could be duplicate rows in either of the original data frames or NaN values in the column which we're using to combine data. And Bard gives me this very interesting bit of code as well. You can use this additional input argument to the merge function called indicator to figure out what records came from which data frame. Indicator equal to true. And here below you find an explanation of what this parameter does. By setting indicator to true, this tells the merge function to return an additional column called underscore merge in the merge data frame, and this underscore merge column will contain left only, right only, or both for each row in the merge data. This will indicate whether the row came from the left data frame or right data frame, or the record was present in both data frames. That is, the record was a match. I must say this is quite cool. I did not know of this before I started this course. So let me actually perform the merge operation and pass in indicator is equal to true and see what the result looks like. I perform the same merge as before. Notice that the value in the underscore merge column says both. So only those records that were present in both columns are present here in the result. And we can confirm this by looking at the unique values of the underscore merge column. The only value for underscore merge in our data frame is both. The possible values are left only, right only, and both, but our data frame only contains the value both, indicating that only matching records from the original data frame are present here in this result. This is the inner join. Let's get Bart to write some useful code for us. I want to know what rows in the employee personal details data frame are not present in the merged employee details data frame. So these will be the employees for which we have personal details, but we do not have professional details. Let's see if Bart can give us some good code for this. This is indeed useful code. It's just hard to read with the formatting that Bard has. I'm going to copy this code over, reformat it, and paste it into our Jupyter notebook. Note the tilde sign. We use a negative predicate for filtering. The basic conditional check is employee personal details of empid is in employee details empid. So which employee ID is present in the employee details, and the tilde negates this predicate. So we get which employee IDs are not present in the resulting employee details data frame. And these are the employees for which we have personal details but no professional details. And we can actually perform this check on the professional details data frame as well. The tilde tells us it's a negative of the predicate. Employee professional details empid is in employee details empid, and we negate the whole thing. So the result is that we know what records are present in the professional details data frame but not in the final merge result, employee details data frame. And here are the missing records for which we have professional details but no personal details. Our common column in both the original data frames was called empid. But what if the common column was named differently? Here I'm going to rename the empid column in the employee personal details data frame to be employee ID. And I'll store this in a new data frame called employee personal details rename. Notice we now have the employee ID column. However, in the employee professional details data frame, the column is still called emp ID. There is absolutely no change there. Now, let's say I wanted to join both of these data frames, but their common columns have different names. I'm not sure how to do it. So I decide to get some prompt engineering help. I have two pandas data frames named employee personal details and employee professional details. How do I combine this information into one data frame? Employees can be identified by a unique employee ID, but the column in the first table is called employee ID and in the second, emp ID. It turns out that there is a very simple solution for this. You pass in the left on and right on input arguments instead of the on input argument. Left on contains the name of the common column in the left data frame. Right on contains the name of the common column in the right data frame. Let's try this out right away. Employee personal details renamed dot merge, employee professional details, left on employee ID, right on emp ID, how is equal to inner. The how parameter allows us to specify how we want the merge to be performed, the join to be performed. Inner join means only matching values from the left and the right data frame will be present in the result. Like I mentioned earlier, the default join operation is the inner join. So even if you don't specify the how input argument, it will still be the inner join that's performed. Let's perform the join once again using left on and right on. I haven't specified the how parameter here, but the result is exactly the same. The inner join is what we've seen and worked with so far. This is where matching records from the left and right data frames are present in the final merged result. But there are other kinds of joins as well for other use cases. Here is a prompt describing a scenario which requires the use of a different join. I have two pandas data frames, employee personal details and employee professional details. How do I combine this information into one data frame? I want to make sure that the personal details of the employee is present in the result even if we don't have the professional details. And employees can be identified by a unique emp ID. So I want the personal details even if I don't have the matching professional details. And here is what Bard has to say. You can use the merge function with the how parameter set to left. The how parameter specifies the type of merge you want to perform. The default value for how is the inner join, but how is equal to left will perform the left outer join. The only change here is that we merge the two data frames together and we specify the how parameter equal to left. The left outer join will include all records from the left data frame even if there isn't a corresponding match in the right data frame. The left data frame is the employee personal details data frame. The right data frame is the employee professional details data frame. We merge on the common emp ID column and how is equal to left to perform the left outer join. All of the records from the left data frame will be present in the result and they'll be padded with nan values if there isn't a matching record in the right data frame. For example, look at the employee at index 0 and index 2. These employee records are present in the employee personal details data frame but not in the professional details, which is why all of their professional information has NANs, salary, position, department ID, and manager ID. Let's verify that we've understood the working of the left outer join. If you look at the shape of the personal details data frame, we have 302 records. If you look at the shape of the professional details data frame, we have 300 records. If you look at the shape of the merged data frame, it will definitely contain all of the records from personal details, which means it should have 302 records, and you can see that it indeed does. Let's use the same filtering predicate as before to see whether there are any records in the personal details data frame that are not present in the final merge result. And you can see that there are no such records. So all of the records from the personal details are present in the result, padded with nan values if there is no match in the professional details data frame. However, there are records in the professional details data frame that are not present in the final merge result, and you can see a sample of these here. When we perform the left outer join, unmatched records from the right data frame are not present in the final merge result. Now, what if we want to switch things around? Here is a prompt for a slightly different scenario. We have the same two data frames, employee personal details and employee professional details, and we want to make sure that the professional details of the employee is present in the result even if we don't have personal details. And of course, the common column is the emp ID. And I bet you could have predicted Bard's response. Just like we used how is equal to left to perform the left outer join, we simply use how is equal to right to perform the right outer join. And you can see the example code here that specifies the same thing. How is equal to right. With the right outer join, all of the records in the right data frame will be present in the result, whether or not they match with records in the left data frame. The data frame on the left is employee personal details, the data frame on the right is employee professional details, and the join type is the right outer join. In the right outer join, all records from the right data frame, employee professional details in our case, will be present in the result, whether or not a match exists in the left data frame. For example, take a look at the employee at index 0. There we only have the professional details, no personal details. So all of the personal details are padded with NaN values. Now let's take a look at the employee personal details shape. We know that this data frame contains 302 records. Let's take a look at the shape of professional details. This data frame contains 300 records. Now employee details, that is the merge data frame using a right outer join, now has 300 records. The number of records is equal to the number of records in the employee professional details data frame. Let's use the same predicate filtering that we are familiar with to see what records in the employee personal details are not present in the merged result. And there are a number of records here. Remember, this is the right outer join. What records in the professional details are not present in the final result? There are no such records in the right outer join. Here is one more possible scenario I present to Bard for a merge operation. I have two pandas data frame, the same two. How do I combine this information into one? That's the same question. I want to ensure that we have at least some details for employees, even if the complete information is not available. This means that if we have the personal details, I want that in the result, or if we have only professional details, I want that in the result as well. The common column is, of course, employee ID. And there is a particular join type for this kind of join as well. According to Bard, you should set the how parameter to full to perform the full outer join. And Bard gives you example code for how you can set the how parameter to full. How is equal to full. Now, this is the code that I'm going to copy over and use in my Jupyter notebook. The full outer join will include records from both the left data frame as well as the right data frame in the result, even if they don't have matching values in the other data frame. Let's go ahead and run this code, and we immediately encounter an error. For some reason, how is equal to full does not seem to work. Let's scroll down below and see what the error is. It says key error full. Bard generated this code and it clearly did not get things right. So let's ask it for some debugging help. I tried to join data frames by specifying how is equal to full, but I got this key error full. Why is this the case and how do I fix this? And Bard has an explanation for me, which it turns out is not entirely right. It turns out that how is equal to full was introduced in pandas 1.0.0. But if you're using an earlier version, you should use how is equal to outer, and it does the exact same thing. It seems like an easy fix is to simply specify the value as how as outer instead of full. Let's first see if this works. Instead of how is equal to full, I'm going to change this to how is equal to outer, and let's see if this performs the full outer join, where the resulting data frame contains all records from both of the original data frames, whether or not they match. Let's run this. Well, there was no error, so this did indeed work. And this result here should contain both personal and professional details for all of the employees that we have. If there is a match, the records will be matched. If there is no match, then either the personal details or the professional details will be present, padded with null values in the other columns. Now let's check our pandas version. Let's see if Bard was right. Now the pandas version that we're using is 2.1.1. It's a pretty recent version, the latest version at the time of this recording. If how is equal to full was indeed available in the latest versions, it should have worked for us. It turns out that this is a bit of hallucination from Bard. How is equal to full is not the right input argument for a full outer join. You have to specify how equal to outer. If you go to the original documentation for pandas for the pd.merge function, you'll see that the valid value to specify for the full outer join is how equal to outer. Now we know that the employee personal details data frame contains 302 records. The employee professional details data frame contains 300 records. And the data frame with the merged result, merged using the full outer join, contains 309 results. And this shouldn't be surprising to you. Records that are in personal details but not in professional details, records that are in professional details and not in personal details are both present in the final result. So if you check to see whether there are any records in employee personal details which are not present in the merged result, there should be no such records. You can see the empty data frame here. Similarly, if you check to see whether there are any records in the employee professional details data frame that are not present in the final result, again, there are no such records. Before we call it a day on join operations, let's just explore a wee bit more. Now, I'm going to read in some more data that I have in some other files here in my datasets folder. Here is some data which contains the employee satisfaction scores. This is in the employee satisfaction.csv file. This file contains the employee ID, the employee name, the engagement survey, employee satisfaction, and the special projects count for the employee. I'm going to read in one more set of data I have about our employees, and that is their performance score in the employee performance.csv file. This once again contains the employee ID, the employee name, the last performance review date, and days late in the last 30 days, and employee absences. Both these data frames, employee satisfaction and employee performance, contain the emp ID column in common. So I say, okay, I can perform a merge operation to combine the data in these two data frames. So I go ahead and apply the techniques that I've learned before. Employee satisfaction.merge employee performance on emp ID. I want to perform the inner join, that is only get matching records in the result. So I do not specify an explicit value for the how parameter. I use the default inner join. The result looks perfectly fine. I think it's correct. But there's something strange here. Notice I have two employee name columns, employee name underscore X and employee name underscore Y. The values in these columns match, but why do I have two columns in the first place? We've been using Bard to help us. Let's turn to Bard again. When seeking an explanation, make sure you give as many details as possible. When I perform this join and I put in the code of the join, I get two columns for employee name with the suffix underscore X and underscore Y. Why is that? And Bard tells me exactly why. When merging two data frames, pandas will automatically rename any duplicate column names to avoid conflicts. By default, pandas will add the suffixes underscore X and underscore Y to duplicate column names. This means the employee name column was present in both of my original data frames, and in order to differentiate between the column value that comes from the left data frame and from the right data frame, the suffixes underscore X and underscore Y were added. Once I understood this, I realized that what I really wanted to do was perform a join operation using both columns, both the employee ID as well as the employee name. So I asked Bard if this is possible. This prompt here is a follow-up question to whatever I had asked before. And it turns out that this is indeed possible. Here is how you can perform a join using two data frames. You specify two column names in the on parameter. This will allow us to perform the join using both employee ID and the employee name columns. So this is what we need to try out now in our Jupyter notebook. When the join uses values in two columns, as it does here on emp ID and employee name, records will match from both data frames only if they match on both the employee ID and the employee name. If the employee name is different for the same employee ID, that's not considered a match. Now, since both employee ID and employee name are join columns, they are present exactly once in the merged result. You can see the first two columns are the join columns, and the rest of the data contains the satisfaction scores and the performance scores. I'll now round off this demo by showing you a few more interesting details about merge operations. I'll now read in one more CSV file containing all of the departments in our organization. This is in the departments.csv file, and I'll read in this data into the department details.csv file. Every department contains a unique department ID and the name of the department. You might want a combined data frame containing the details of all of the departments and employees who belong to that department. And you can get this by performing a merge operation with a specified join type. I've invoked the pd.merge function. The left data frame is department details. The right data frame is the employee professional details data frame. We'll perform the merge on the department ID column, which is the common column across both data frames. The join type is the inner join that will only give us matching records in the result. So, only if a department has an employee will it be present in the result, and only if an employee belongs to one of the listed departments will that employee's record be present in the result. Now, this join is a little different because there are many employees who will belong to the same department, which means the relationship between the departments and the employees is a one to many relationship. One department contains many employees. While performing this merge operation, you can actually validate that this is indeed the case using the validate input parameter. Here, validate one to many will ensure that the relationship between department and employees is a one to many relationship. Let's now run this code, and the fact that there was no error means that the validation was successful. This is indeed a one to many relationship, and the merge operation has validated that. We now have a merge result which shows us the name of the department that each employee belongs to. Let's switch around our validation to something that's obviously wrong. We are joining the department details with the employee professional details. It's still an inner join, how is equal to inner, but I've set the validate parameter to be many to one. What I'm implying here is that one employee is associated with many departments, and that's clearly not the case. A department has many employees and not the other way around. So this validation should fail. And if you perform the merge operation, you should see an error like this on screen. Merge keys are not unique in the right dataset. It's not a many to one merge. I'll now read in one last bit of information that I have for my organization, and that is a list of all of the managers. And this will be in the manager details data frame. Every manager has an ID and a name. Let's perform a merge between employee professional details and manager details. The employee professional details data frame contains a manager ID column, and this is the column on which we'll perform the join so that we know the name of the manager to whom an employee reports. If you think about the relationship between employees and managers, many employees report to the same manager. So this is a many to one relationship, and that's what I've set my validation to. Validate equal to many to one. When I run this code here, you can see that the merge goes through successfully and the validation has passed. Many employees do report to a single manager. Here I am on a brand new notebook called timeseries.ipynb. As the name implies, in this demo, we'll see how we can use pandas to work with time series data. And of course, we'll get some prompt engineering help using Gen AI tools along the way. Let's import some of the libraries that we'll need. We'll import pandas as PD, and we'll also import the date util library to parse dates in our data frame. Time series data is a type of data where observations are collected, recorded, or measured at specific and equally spaced time intervals. In time series data, each data point is associated with a timestamp, which represents when that data was recorded. Now, a very common type of time series data is stock price information, and that's what we are going to be working with in this demo. I've downloaded the stock price information for Tesla from the Yahoo Finance site, available at this URL here. And this is what I'll read into my pandas data frame using pd.read_csv. This file contains stock price information starting the 4th of January 2016 for Tesla. For each trading day of the year, we have the open, high, low, close, and the adjusted close information, along with the volume of stock traded. The data frame is already sorted based on date. If you look at the tail of the data frame, you'll see that we have records going all the way through to the 12th of October 2023. Before we perform any time series analysis, it's important to check whether the column that contains the date or timestamp information is of the right type. Let's run the info method, and you can see that the date column is of type object it's not of type datetime64. So this is something that we'll have to fix. Now you know how to use the pd.toDateTime function for this. Here is another way you can parse the date information into the right format. The dateutil library that we imported contains a parser.parse function that you can apply to the date column and then assign this to the date column. This will give us all of the dates in the right date time format. If you now look at the D types for the Tesla data frame, you can see that date is of type datetime64. Yahoo Finance data usually comes in the sorted order of dates, but now that we have the date in the right format, let's ensure that the sorted order is correct by sorting our data frame based on date using sort values. Here we sort values on the date column, we sort in the ascending order, so the earliest date comes first, and we sort in place, which means that the Tesla data frame will be updated. The tail of the data frame gives us the latest dates for which we have information, the 12th of October 2023. Time series analysis involves the use of many mathematical models, such as the ARIMA model or the Prophet model. We won't be using those. Instead, we'll start off with a simple visualization. Here I am on ChatGPT in a brand new chat, and I pose this prompt to ChatGPT. I have a pandas data frame with time series data, stock prices for Tesla. Is there a way I can view a line chart of the adjusted close price over the dates for which I have data? Visualizing time series data is a powerful technique to understand it. ChatGPT gives me a sequence of steps for this. First, make sure that we have pandas and matplotlib using pip install. We then need to import the necessary libraries. We need to make sure that our date column is in the datetime format. We've done all of this. We then need to sort our data frame based on the date column, and this is something we've done as well. And finally, we can create the line chart using matplotlib. So really, that's the code that I'm looking for. When I looked at this visualization code, I realized I can't really use it directly because the name of the data frame is df, which means I'll have to copy the code and make a bunch of tweaks. I was feeling kind of lazy to do that. Plus, I wanted ChatGPT to generate future responses using the right variable for the data frame. So I follow up with another prompt to fix this. Could you use Tesla underscore data as the name for the data frame and give me the same code? The code I realized was correct. I only want to change the name of the data frame, and ChatGPT obligingly does this for me. Let me copy over the right bits of information. The first thing I need to do is import the matplotlib library. Import matplotlib.pyplot as PLT. This is what we'll use for plotting. Next, let's copy over the visualization code for the line chart. Let me just format this a bit and then we'll see what's going on. Plot.figure actually plots the figure within which the line chart will be drawn. 12,6 is the size of the figure. 12 inches is the width. 6 inches is the height. Plt.plot will actually plot the line chart. The date will be along the x-axis, adjusted close along the y-axis. The label will be Tesla adjusted close, and the line will be in the blue color, color equal to B. The code on lines 5, 6, 7 sets up the labels for the x-axis and y-axis respectively, and also sets up the chart title, Tesla adjusted close price over time. Plot.legend will show a legend for the chart, and plot.grid set to true will display a grid background for the resulting visual. And here is what the chart looks like. You can see that Tesla stock price was kind of down in the dumps up to about 2020, and then it just took off, and then it has been up and down over the year 2023. I find that it's often hard for me to remember the exact syntax of the different kinds of charts, whether it's matplotlib or any other charting library. ChatGPT makes things easy for me. Now I switch back to ChatGPT and I ask, can I view the open high, low close, and adjusted close all in the same line chart? This is definitely possible. And here is ChatGPT's code for this. Because I had corrected it to use Tesla data as the name of the data frame, it continues to use that variable name, making it very easy for me to copy paste this code into my notebook. Here is the code to visualize multiple lines on the same plot. The main part of the code is on lines 5 through 9. This is where we plot date on the x-axis and open high, low close, and adjusted close on the y-axis using different colors. This time the legend will actually be useful. This is what the chart looks like. It's hard to tell apart the different lines because they track each other so closely. But all of the information that we ask for is available here in this line chart. Let's say this is too much information for you to take in and you want to cut down the information that you view in your line chart. Here is a prompt which requests ChatGPT to do this. Could you display a chart with only the adjusted close for the year 2023? And ChatGPT obligingly generates code which performs the filtering operation on our data frame and then displays a chart using the filtered data. Let's paste this into our notebook and take a look. The filtering operation is up top on line 2. We access Tesla data 2023 by filtering date greater than equal to 1st of January 2023 and less than equal to the 31st of December 2023. And then on line 7, we plot the records from this filtered data frame, Tesla data 2023. And that's really the only change that was made. We just filtered the records and plotted the filtered data. You can see that it started off pretty much at a low in the beginning of 2023. That's because of all of the volatility that was in 2022. And since then, the stock has mostly gone up. When you're working with time series data, a common practice is to set the date values as the index of your data frame. The default index for our data frame is essentially a zero-based integer index. I'll now change this. I'll set the index to be equal to the values in the date column. So Tesla data dot index equal to Tesla data date. And we now have a new custom index for our data frame. Updating the index means that we can use the lock indexer to look up the value of Tesla stock price at specific dates. Here I use the lock indexer to look up Tesla's stock price on the 18th of March 2020. This is around when COVID shut down the world. Tesla's adjusted close was at $24. Somewhere near the end of 2021, Tesla's stock price reached its highs. Let's see what it was. On the 18th of November 2021, it was at around $365, the adjusted close. The time series data that we have, Tesla stock prices, is at a daily granularity. But you may not always want to visualize this data at this granularity. Maybe you want to perform some kind of aggregation and then visualize this data. This is what I asked ChatGPT. Here is the prompt for the code that I want generated. I want to compute the average monthly adjusted close of Tesla stock price and plot this monthly average in a line chart. Could you please write code for this? Now, there are many different ways of accomplishing this, and the first time around, ChatGPT gave me something that was quite complicated. There's a lot of aggregations going on, then a map function, and I felt that the code was just too hard for me to understand. As I was trying to understand this code, that's when I remember that someone at work had mentioned that Pandas has this grouper object that makes it very easy to aggregate and visualize your time series data at different aggregation frequencies like monthly, weekly, and so on. So I asked ChatGPT to use this grouper object. Could you use a pandas grouper to perform the grouping and simplify this code? I also want ChatGPT to generate code that's simple enough for me to understand and maintain. Let's see what ChatGPT has to say now. And the code that uses the PD grouper is so much simpler to understand and parse. Now it's hard to see what's going on here because we have to scroll to the right each time. But let me copy this code over and paste it into a Jupyter notebook and we'll see how it actually works. You'll see how simple things are using the PD grouper. Notice on line 2, we compute the monthly average adjusted close price by grouping the Tesla data using a pd.grouper object. The pd.grouper object is a flexible way to define how you want to group and aggregate time series data when using the group by method. It's particularly useful for grouping time series data by time periods, such as days, months, quarters, or years. Here I've instantiated a pd.grouper. I've specified date as the key, indicating that's what contains my time series data. Frequency equal to M will group the data by month. Now that I have the data grouped by month, I access the adjusted close and compute the mean. This will give me the average adjusted close for each month. This is what will be stored in the monthly average adjusted close data frame, and we'll plot the values in this data frame on line 6. On the x-axis, we'll use the index, that is the date values. On the y-axis, we'll plot the monthly average adjusted close. And here is the plot for the monthly average adjusted close for Tesla. You can see that the curve is much smoother because of the average aggregation that we've applied. Another way to perform monthly aggregations on time series data is to use the resample function and specify M, capital M, for the monthly frequency. Here we access the open, high, low, close, and adjusted close for Tesla stock price, resample at a monthly frequency, and then compute the average prices for these per month. The resample function to resample time series data at different frequencies only works if the index of your data frame is a date time like object. Observe the resampled data frame with 94 records. Notice that each index is the last trading day of the month. 31st of January 2016, 29th of February 2016, 31st of March 2016, and so on. And the prices computed are the average prices at this monthly frequency. And with this, we can actually just invoke the plot function and plot this monthly aggregation of all prices. Again, this is a smooth curve, and we have specified markers for the actual data points that make up this line. If you look at the contents of our Tesla data frame, you can see that the index values of this data frame have been set to the dates of the stock price information that we have. We also have a date column that contains the actual dates. Now, let's say I wanted to sort this data based on the date column and I use sort values. This will result in an error. We just performed the sort operation earlier in this demo. Why is this an error now? And you can see what the error is here at the bottom. Our data frame has changed now. Date is both an index level as well as a column label, which means when you use sort values, Pandas is not sure about what value of date you want to use for sorting. So how do you actually sort this data frame? Back to ChatGPT for debugging help. I tried sorting my Tesla data frame using this code, sort values, but I got this error. Date is both an index level and column label, which is ambiguous. What does this mean and how do I fix this? ChatGPT correctly identifies our current scenario. The date column in your data frame is being interpreted as both the index and a regular column label. This can happen if you set the date column as the index of your data frame at some point and you also have the original date column. ChatGPT's suggestion here is to reset the index to no longer use the date index label and use zero-based indexing. But really, this is not what I want. So I follow up with another question. I do not want to reset the index. Is there another way I can sort by date? It turns out that I can just use the sort index function. Sort index makes it very clear to pandas that I want to sort based on the index labels. And this will resolve the ambiguity about whether we should use the column or the index label to sort when we specify date. So let's use sort index in place is equal to true and sort our Tesla data based on date. This data was already sorted. I just wanted to show you how you could sort by date when the date is used as an index label and is also a column in your data frame. Another common operation that you perform with stock price data is to compute the change in price from one period to another, that is, the delta in your price information. Let's ask ChatGPT how we can accomplish this. I want to compute the daily difference in price on Tesla stock prices using the adjusted close column. Is this something that can be done easily in Pandas? The response that I get from ChatGPT isn't exactly what I want. It tells me how I can compute the percent change, PCT underscore change in price from one day to the other. But I want the absolute change in price. This means ChatGPT did not understand what I wanted, so I follow up with another query. I want the absolute price difference from one day to the next and not the percentage change. Also, I want this stored in a column called price underscore difference. And ChatGPT gives me the right code this time around. Let me just copy this code over and we'll look at what it does in our notebook. When you have an ordered data frame containing time series data, you can invoke the diff function on any numeric column in your data frame, and this will compute the deltas or the differences between every consecutive pair of records. Let's take a look at the resulting data frame and things will become much clearer. The value of the price difference for the first record is simply NaN because there is no previous record to compute the difference. Let's look at the record at the second row. This is computed by looking at the adjusted close for the 5th of January 2016 and subtracting from it the adjusted close on the 4th of January 2016. The price difference for every day is computed by subtracting the previous day's adjusted close from the current day's adjusted close. And you can see the price difference computed all the way through to the end of your data frame. Here are the last 5 records. Now that we have the actual price difference deltas, let's go back to ChatGPT's previous response where it showed me how I can compute the daily returns, that is the percentage change in the prices from one day to the next. This is the PCT change function, and we'll now invoke this on our data frame. The PCT change function computes the returns on your data. So from one day to the next, we'll see by what percentage Tesla's adjusted close varies when we use the PCT change function. Whenever you're using stock price data for any analysis or prediction, computing the daily returns is an important pre-processing step. You'll find yourself using this really often. Notice we have a new column called daily return in our data frame. Computing the price difference and the daily return has resulted in some null values in our data frame. So let's go ahead and drop those null values. We now have a data frame with no nulls or missings. Let's view the visualization technique that we've learned before to visualize the daily return data. On line 4, you can see the plot, date on the x-axis, daily return on the y-axis. And this is what the daily returns look like. You can see the spikes in early 2020 when the stock was really volatile and also in late 2018. Rather than viewing daily returns at a daily granularity, we can actually smoothen this using a rolling window. Notice I invoke the rolling function and specify window size 7. The mean function over the rolling window will compute the aggregate daily returns over a 7-day period. The first mean will be computed from day 1 to day 7. The second mean, the window will roll over from day 2 to day 8, and then the average will be computed. And then the window will roll over again from day 3 to day 9, and then the average will be calculated. And this will go on till the end of the data. And this will give us a much smoother result. This is how the daily return of Tesla stock price varied over a 7-day rolling window period from the time for which we have records. Using this rolling window, you can perform any aggregation on your data. Here is the standard deviation of Tesla stock prices over a 7-day rolling window. And this is what the resulting line chart looks like. Observe that in early 2020, when Tesla's stock price was moving widely, the standard deviation was quite high. You can see the spike there. In this demo, we'll explore something that generative AI tools such as ChatGPT and Bard are great at: selecting the right visualization based on the data that you have and generating code for that visualization. Here I am on a new notebook called visualizations.ipynb. The common Python libraries that you'd use for visualization include matplotlib, which we've already installed on our machine. We'll also be using Seaborn, so go ahead and pip install the Seaborn library as well. Seaborn is great at visualizing statistical data and often produces plots that are far better than using plain matplotlib. The Seaborn version that I'm using is Seaborn 0.13.0. You'll find that when you generate code for visualizations using ChatGPT or Bard, the generative AI assistant will often pick one of Matplotlib or Seaborn to create your visuals. So I'm going to set up imports for common libraries that we might use: pandas, numpy, matplotlib, Seaborn, and dateutil. We'll be using several different datasets here in this visualization demo. The first dataset that we'll work with is the customer value analysis dataset that's available from this link here on Kaggle. This is the dataset that I read in using the pd.readcsv function. This dataset contains records for customers of an insurance company, and every customer has been ascribed a customer lifetime value. And you can see other details here, such as the class of the vehicle and the size of the vehicle that the customer has insured with the company. This is a data set with a large number of attributes. So let's use the dot columns member variable to view what columns we have. Observe that we have a column named income, and now I'm curious about how this income is distributed across the customers. Let's turn to ChatGPT to help figure out what kind of visual we can use for this. I have a pandas data frame called CVA_DF, which contains the income details for different customers of an insurance company. I'm curious to see how income values are distributed. What kind of visualization can I use for this? And ChatGPT comes up with a whole bunch of meaningful visualizations that I can use. The first is a histogram to see the frequency distribution of income values within different income ranges. And ChatGPT has given us the code for a histogram as well. Another visualization that ChatGPT suggests is a kernel density plot, which provides a smooth estimate of the probability density function of the data. And we have the accompanying code. You can also visualize the distribution of your data using box plots or violin plots. Well, there are a whole series of visualizations that we can choose from. Let's start with the first option, the histogram. I'm going to copy this code over and paste it in my notebook and make a few tweaks. Because we are visualizing the distribution of one variable, this is referred to as a univariate visualization or univariate analysis. We use the plot.hist function to plot a histogram of the income values. And we've set the number of bins to 20. Let's see what the histogram looks like, and I'll explain what the histogram represents. Along the x-axis, we have bins representing ranges of income values. And along the y-axis, we have the number of records in each income range. The first bin with a very large bar is the income range between $0 and $5,000. And you can see that there are more than 2,500 records in this income range. The histogram was a great visualization to view income distribution, but let's look at this KDE plot next. Notice that we use SNS, which means we are plotting this using Seaborn. Instead of income, I've changed to view the distribution of the total claim amount for the different customers in our dataset. SNS.kde plot creates the kernel density plot of whatever variable we are visualizing. When you run this code, you might encounter a warning, and that's because of this input parameter shade is equal to true. This parameter has now been deprecated, and the recommendation is that you use fill equal to true instead. So I'm going to change shade to fill, and the warning disappears. ChatGPT's training data goes only up to September 2021 at the time of this recording, and this deprecation probably happened after that, which is why ChatGPT generated code which contained deprecated parameters. The KDE curve is used to visualize the distribution of data using a smoothened curve. On the x-axis, we have the values for the total claim account, and on the y-axis, we have a probability score representing the concentration of data points at a particular value. You can see that the peak occurs somewhere around $400, indicating that many records are concentrated at that value of claim amount. I find that ChatGPT is very helpful in helping me understand these different visuals. What is the KDE curve and how do I interpret it? Gives me all of the details for this particular visual. You can see that the KDE curve plots a smooth distribution by using a mathematical function called the kernel at each data point and then summing up those kernels to create the smooth curve. Peaks in the curve represent values where there is a high concentration of data points. That covers the basics for the KDE curve. There are other details here that you can read to understand it better. Now let's go back to the box plot visualization for our data, and we'll see how we can use the box plot to visualize the distribution of the total claim amount. SNS.boxplot means that we are using the Seaborn library to plot this visual. Notice that I pass in the total claim amount as the value of the X input parameter, and this will generate a horizontal box plot. Now, I don't know about you, but I find the horizontal box plot a little hard to understand. So what I'm going to do now is simply change the X to Y. And now because the total claim amount is being plotted along the Y-axis, this will give us a vertical box plot. I love using a box plot to visualize the distribution of my data because it gives me so many summary statistics in one glance. The center line of the box plot represents the median value of my data, which is somewhere around $400. That's the claim amount. The lower edge of the box represents the claim amount at the 25th percentile, and the upper edge of the box represents the claim amount at the 75th percentile. The box thus represents the interquartile range of our data. Now notice the two horizontal lines above and below the box. Those are the whiskers. Whiskers are usually drawn at 1.5 times the interquartile range from the edge of the box. The points that lie outside of the whiskers represent the outlier data points. If you're not very familiar with the box plot, you might forget what the box plot represents. And this is where you can ask ChatGPT for help. Could you explain what the box plot represents? And this will give you the complete details for your plot. What the box represents, what the lines inside the box represent, the whiskers, and the outliers, everything that we just discussed. I now want to view my income data in a slightly different way, so I turn to ChatGPT for help. I want to view the cumulative distribution of income. Could you write code to generate a plot for this? I'm not even sure what the plot will look like. I didn't know the name for the plot, but it's something called the ECDF, or the Empirical Cumulative Distribution function. Here is the code that ChatGPT has generated. I'm now going to paste it into my Jupyter notebook and we'll understand what the code does. In the ECDF plot, we visualize for each data point the fraction of the data points in our dataset that are less than or equal to that particular value. In order to generate this plot, we first have to sort the income values in ascending order. We do this on line 2. The Y values represent the probability, so we then arrange the sorted income from 1 to the number of data points that we have, and then we divide by the number of data points. This will give us the Y-axis that represents cumulative probabilities, starting at 0 for the lowest value of income and going up to 1 for the highest value of income present in our dataset. np.arange is used to generate the sequence of steps from 1 through to the number of data points that we have. And we divide each value by the number of data points, that is the length of the sorted income list, so that these values are represented in the form of decimals from 0 through 1. We then plot the ECDF plot, sorted income on the x-axis, and the cumulative probability distribution, the y values, on the y-axis. And this is what the ECDF plot, or the empirical cumulative distribution function of income, looks like. You can see that a large number of records have income values at 0, and then there is a little jump and income values start off at about $10,000 a year. Now let's see how we can visualize some of the categorical data present in our dataset. My CVA DF that contains the customer value analysis data has a column called marital status. Could you suggest a visual I could use to view the number of customers for each value in this category? So I want to see the distribution of customers for each value of marital status. And ChatGPT rightly suggests a bar plot for this kind of visualization and generates code for a bar plot using matplotlib. I've seen that visualizations in Seaborn look better, so I ask a follow-up question. Could you use Seaborn for this instead? And ChatGPT immediately obliges and produces code that I can use directly. Let's paste this code into Jupyter and see what it does. I won't worry about the styling of the plot. Those are things you can figure out by yourself. On line 5, we compute the value counts for every categorical value in the marital status field. On line 10, we call sns.barplot. Along the x-axis, we plot the index of the marital status counts panda series. This will have the categorical values for marital status, and on the y-axis, we'll plot the actual count values. When I run this code, I get a warning. That's because Seaborn recommends that I assign the x values to the hue parameter. So I change hue to point to marital status counts index, and this warning will disappear. And we get a nice little bar plot showing the count of records in each of the marital status categories: married, single, and divorced. Now let's look at a different way to visualize categorical data. In my CVA DF, I have a sales channel column. I want to see what proportion of records are in each category of sales channel. what's the best visualization for this? ChatGPT thinks the best visualization for this is a pie chart. A pie chart allows you to use the sections of the pie to represent proportions in your data. Let's paste this code into our notebook. Once again, we compute the value counts for the different values in sales channel. That is the sales channel counts on line 2. On line 7, we use plot.py, pass in the sales channels counts, and auto percent set to 1.1f will display percentage values up to 1 decimal point for each section of the pie. And here is what the resulting pie chart looks like. Sales channel agent is the largest proportion with 38.1% of the pie. So far, we've looked at a number of univariate visualizations. Now let's turn our attention to some bivariate visualizations where we'll visualize the relationship between two variables in our dataset. Here is my ChatGPT prompt. I'm curious about the distribution of the number of policies in my customer value analysis data frame. However, I want to view the distribution by policy type. So I want to see the distribution of number of policies by policy type. Is there some way I can do this? Now, there are several ways to visualize this information, and ChatGPT suggests two. One is a grouped histogram, and there is the code for that. And the second technique it suggests is using a grouped box plot, and it gives me the code for the grouped box plot as well. But let's say you now have an opinion about what kind of visualization you're actually interested in. You want to visualize this using a facet grid in Seaborn. So I asked ChatGPT a follow-up question. Could you use a Seaborn facet grid for this? Seaborn's facet grid allows you to create multi-plot grids where each subplot in the grid displays a different subset of the data based on one or more categorical variables. Well, ChatGPT is up to the task here and it immediately generates code for the Seaborn facet grid. Let's see what the code does. We instantiate a facet grid to display the histogram on line 2. Notice the column for the facet grid is based on policy type. We then use map underscore data frame on the facet grid to specify the kind of plot that we want to visualize in each facet. I want to visualize a histogram, so sns.histplot is what we've passed in. We want to view a histogram distribution of the number of policies, and that is the x value that we pass in. And we also want to view the KDE curve, so KDE is equal to true. The rest of the code here is just formatting the visual, so I'll leave that to you to understand. Let's take a look at what the visual looks like. Observe that we have three different histograms for the three types of policies: corporate auto, personal auto, and special auto. And for each policy type, we have a histogram distribution of the number of policies. Sometimes you might want to view a relationship between two continuous variables. I'm curious about the relationship between income and total claim amount in my CVA DF. What kind of chart can I use to view this information? And ChatGPT very correctly assesses that what you need here is a scatter chart. A scatter chart or a scatter plot is what you'd use to visualize the relationship that exists between a pair of continuous variables. On line 3, we have the plot.scatter function from matplotlib used to display the scatter plot between income on the x-axis and total claim amount on the y-axis. And from the nature of the scatter plot, it's pretty clear that there is no real relationship between income and the amount claimed. There is no real to the distribution of the points on the scatter plot. Another kind of relationship you might want to express is one between a categorical variable and a continuous variable. Here's my prompt. In my CVA DF, I want to represent the relationship between marital status and customer lifetime value. What chart can I use for this? And ChatGPT's response recommends that I use either a box plot or a violin plot to represent this relationship. Since we are familiar with box plots, I'll pick that option and copy the code over for the box plot. And let's understand what this code does. We construct the box plot using Seaborn. sns.boxplot is the function. The data frame with the data is CVA underscore DF. On the x-axis, we plot the different values for marital status. On the y-axis, we plot the customer lifetime value. The palette parameter specifies what colors the resulting box plot will be displayed in. Now it turns out that this results in a warning because you cannot use the palette parameter without setting the hue. So I'm going to change this to have the hue be based on what we display on the x-axis, the marital status. The box representations for the different values of marital status will now be in different colors. The warning has disappeared, and here is what the resulting box plot looks like. Now, I'm not really happy with this visualization. The boxes are so tiny that I can't tell what's really going on. Let's see if ChatGPT can help us fix this. Here is my prompt. I'm setting up a box plot using this code, and here is the code for the box plot. The outliers in my data tend to make the boxes very small. Is there a way to fix this? ChatGPT suggests two possible techniques. The first is to adjust the y axis scale. You can change the scale of the y axis in your box plot to logarithmic scale, and this will help spread out the y values and make the box plot more readable. The second technique that ChatGPT represents is to clip outliers by limiting the visualization to a specific range of y values, excluding the extreme values of outliers. Now, the first technique sounds interesting. That's the one I'm going to try out first. Let's copy this code over and get it into a readable format in our Jupyter notebook. The main change here is the plot.yscale function invoked on line 9. Yscale log sets the y-axis scale to logarithmic. And here is what the resulting box plot looks like. It's so much more readable. Notice the y-axis, we have values 10 raised to 4, then 10 raised to 5. The y-axis is in logarithmic scale. You can tell that there is not much difference in the customer lifetime values for different categories of marital status. The size of the boxes and the median values are more or less the same across all three categories. For completeness, let's try the second technique to improve this visualization, where we clip outliers by limiting the range of the y-axis. I'm going to copy this code over and tweak it once we are in our notebook. The main change to our original box plot code is the y value range that we have set on line 2. Here the y values are between 0 and 10,000 to start off with, and we set the y limits on line 10 using plot.ylim. When I executed this code, I felt the y range was too limiting, so I increased it to 15,000 rather than 10,000. I ran this code again. I felt still this y range was too low and I can up it to something higher. Let's make it 25,000. And this time around, I felt the box plot was much more meaningful. We can clearly see the size of each box and the median values for each marital status category, and we can also see most of the outliers. Not all the outliers are present, but overall the visual is much easier to read. So far, we've used Matplotlib and Seaborn to visualize our data. Matplotlib gives us very granular control over our visualizations, and Seaborn is a higher level library. It's simpler and more intuitive to use than Matplotlib. It also gives us better looking visuals. In this demo, we'll see how we can set up interactive visualizations in Python using the Plotly library. Plotly emphasizes interactivity in data visualizations. Users can zoom, pan, hover over data points to see details, and interact with plots in a web-based environment. Go ahead and pip install the Plotly library. The -- upgrade flag is to upgrade Plotly if you already have it installed. We'll first use Plotly to set up an interactive time series visual, and the stock price data that we'll visualize is the stock price of Nvidia. I downloaded this data from this URL here on finance.yahoo.com. I'll read this data into a data frame. You can see that we have open, close, high, low, and adjusted close stock prices starting from the 4th of January 2016. If you look at the tail end of the data frame, you can see we have stock price data up to the 12th of October 2023. The first thing we need to do here is convert the date column to be of the date time format, and I'll use the dateutil parser.parse function to perform this conversion. Once this is done successfully, let's go and sort the data frame based on the values of date. Our time series data will now be in the ascending order of date. And with that done, we are now ready to visualize our data, and we need to take ChatGPT's help to see how we can work with Plotly. I have a pandas data frame, NVDA data, containing Nvidia stock prices with columns date, open, high, low, close, adjusted close. How do I plot an interactive chart using Plotly? And ChatGPT gives me an entire sequence of steps for this, starting off with the installation of Plotly, which we've already done. Then it asks us to import our libraries, load our data frame, and then create an interactive chart using Plotly Express. Plotly Express is a high level visualization library built on top of Plotly, and it provides a simplified and concise interface for creating a wide variety of interactive visuals. So, if you're working with Plotly, it's easier to use Plotly Express. Let's go ahead and copy the code over for this line chart, and then we'll take a look at what exactly the code does. Notice that it references the PX library for interactive visualizations, and I've added a fig.show to display the figure, but I haven't imported Plotly Express yet, and that's why you see this PX not defined error. If you scroll to the top here on ChatGPT's response, you can see the import statement that I forgot to add in. This is what I'm going to copy over now. To plot an interactive line chart, all I do is call px.line, pass in the Nvidia data frame. X-axis is the date, y-axis is the close price. We can ignore the warning here that has to do with the use of a deprecated library from within Plotly. We can't do anything with that. And here is our beautiful line chart with interactivity built in. Notice as you hover over the data points, you automatically get a tooltip. We didn't have to do anything special to have the chart be interactive. Now, let's go add some more bells and whistles to this line chart. Back to ChatGPT. Time series charts in Plotly allow you to configure known as a range slider, which allows you to zoom into particular sections of the chart. This is what I want, and this is what I've asked ChatGPT to generate code for. ChatGPT in its response goes above and beyond. Not only does it configure a range slider, but it also sets up buttons to allow you to view the data for the last day, the last 5 days, the last month, and so on. Let me paste this code in and I'll show you what the code does. On line 2, we have the px.line function in Plotly Express, which draws the line chart. On lines 5 through 15 is where we configure the lines chart with a range slider and buttons. We call the update x-axis function to add additional components to the x-axis for interactivity. Range slider visible equal to true is what will display the range slider. In addition to the range slider, ChatGPT also generated code for a range selector. The range selector displays buttons allowing you to view the chart for a particular time period. On line 7, we have count is equal to 1 and step is equal to day. This will show you how the stock price moved for the last one day. On line 11, we have count is equal to 6 and step is equal to month. This will show you how the stock price moved for the last 6 months. Let's take a look at this updated interactive line chart. Notice the range slider at the bottom. You can slide the left side or the right side of the range slider to zoom in to the end of the period that you're looking at or to the beginning. Or you can zoom in from both ends. Notice that the chart changes automatically. Notice the buttons that we have here. These are the range selectors. Here is the stock price for the last 1 year. Here is the stock price of Nvidia for the last 3 months. And here is the stock price for the last day for which we have data. With Plotly, it's super easy to add interactivity to your chart above and beyond what's available by default. Let's go back to ChatGPT with a follow-up prompt. That worked great. The previous code was indeed perfect. Could you plot all 4 lines in the same plot, open, high, low, and close? And ChatGPT promptly makes a few tweaks to the previous code that it had generated and gives us the new code for our updated requirement. Let's copy this code over. The main change here is to the code on line 2. We call px.line pass in Nvidia data. On the x-axis, we still have the date, but on the y-axis, we have a list of values, open, high, low, close. This will plot 4 different lines on our chart along with a legend. We still continue to have our range slider and range selector. Let's take a look at what this chart looks like. We now have 4 lines very close to one another representing open, high, low, and close. And this legend that you see on screen, that's interactive as well. If you double click on any of the lines here in this legend, you'll isolate that line and view only that data. Here I can see only the opening price. Now I've unselected that and I double click on high, and that shows me only the high prices. I unselect that and I double click on close, and this gives me only the closing prices. So if you have multiple values represented in a plotly visual, you can isolate individual values by double clicking on the legend. The line chart is not the best way to represent your open, high, low, close values for stock prices. Is there a better chart in Plotly to display this? This is my query to ChatGPT, and ChatGPT immediately pipes up with candlestick chart. The candlestick chart is available built in Plotly and is a special visualization for financial data. We'll need to import a slightly different library for this, Plotly graph object. So set up that import in your Jupyter notebook, and the rest of the code for the candlestick is available here on ChatGPT as well. I'm just going to copy this code over. We instantiate the Plotly figure object using go.figure, and then we instantiate the candlestick using go.candlestick. And then the columns that contain the open, high, low, and close values for Nvidia stock price. Now, at first glance, the candlestick may not look very different from a line chart. But if you actually zoom in to a small section of the data, and you might have to zoom in to the actual chart as well, you can see how the candlestick chart is different. Every element of this chart is a candlestick. Red candlesticks represents days when Nvidia stock opened at a higher price and closed at a lower price. Green candlesticks represent days where Nvidia stock opened at a lower price and closed at a higher price. You can hover over the individual candlesticks and view the open, high, low, and close prices. The box-like structure in the candlestick represent the opening and closing prices, and the little protrusions above and below the box represent the high and low price for the day. Plotly is great for interactive visualizations beyond just time series data, and that's what we'll explore here in this video. The data that we'll work with is the insurance data that we've seen before. This is the cleaned dataset that I'm reading into the insurance DF data frame. You're familiar with this data needs no introduction. Now, there are certain relationships that I want to explore with this data, so I'm going to head over to ChatGPT and seek some help. Here is my prompt. I have some insurance details for customers in a pandas data frame insurance_df. I'd like to view the relationship between age and charges using an interactive Plotly visualization. Could you help with this? ChatGPT's response is always very step by step, so it talks about installing Plotly, importing the libraries, loading my data frame, and so on. But we've done all of that. Let's go directly to the actual meat of the code, and let's copy and paste this code into our notebook. Observe that ChatGPT has recommended the use of a scatter plot. This is a great way to visualize the relationship between two continuous variables. We call px.scatter. The data is in the insurance DF data frame. That's the first input argument. On the x-axis, we plot age, y-axis charges, and then we have the title of the chart, insurance charges versus age. And this is what the scatter plot looks like. There exists a clear linear relationship between age and insurance charges. As age goes up, insurance charges tend to rise. Also, there seem to be three separate bands of charges. Since we're using Plotly to display this information, the plot is interactive by default. You can hover over the individual data points and get a tooltip telling you what exactly that data point represents. Plotly also gives you a number of tools that you can use to interact with your visualization. For example, you can zoom into a particular portion in the chart, or you can zoom out and view the chart in its entirety. Now, all of the data points in the scatter plot are of the same color. Let's say I want to add in more detail to the scatter plot. So I'll take ChatGPT's help for this. Could you update this to have the points displayed based on the region the customer is from? So I want the points to somehow indicate the region for that customer. And here is the code for this. The main change is to the actual scatter plot on line 2. X is age, Y is charges. The color of the data points will represent the region that customer record is from. That is the significant change that you can see here in this visualization. Adding color will allow you to see if there is a pattern for insurance charges across regions. Once you add in color, you automatically get a legend with your plot as well. I'm now going to single click on the individual regions to deselect those options. So I've deselected Southwest. I'll deselect Southeast. So those points have disappeared. I'll deselect Northwest, and we are only left with the points for the Northeast region. And of course, just as easily as you deselected the regions from the legend, you can click on them and select them once again to view the data points for all of the regions. Now, you can make the scatter plot even more meaningful, and I'll show you how you can get ChatGPT's help for this. My prompt here is requesting for code such that the BMI of the customer is represented using the size of the bubbles in the scatter plot. Let's see if ChatGPT gives us the code for this, and yes, indeed it does. The change is actually very simple. It's just another configuration that we have to pass into px.scatter. We specify the data frame, x-axis age, y-axis charges as before. The color of the data points still represents the region for the customer. The size of the data points will represent the BMI values for each customer. Larger the bubble, higher the BMI value. And this is what our interactive scatter plot looks like. Observe that they are relatively larger size bubbles off to the top end of the chart. That's when insurance charges tend to be high. If you now hover over the individual data points and look at the tooltips, you'll get all of the information that we've displayed here in this chart: region, age, charges, and BMI. We'll close out this demo by looking at one last visualization to see the relationship between pairs of variables. And that is the heat map used to display the correlation coefficients between pairs of variables. Now I'm going to compute the correlations of all columns in my data frame except for sex, region, and smoker. Those are categorical values. The remaining columns are all numeric values. The core function in a pandas data frame, which is what I have invoked, will compute the correlation matrix. A correlation matrix represents the correlation coefficients between every pair of variables in your data. This quantifies the statistical association or relationship between pairs of variables. Correlation coefficients measure the strength and direction of linear relationships between variables, indicating how closely the variables move together. A positive correlation means that variables move in the same direction. If one goes up, the other does as well. A negative correlation indicates that variables move in opposite directions. If one goes up, the other tends to go down. Correlation coefficient values range from -1 to 1. Notice our variables placed along the rows and columns of this correlation matrix. If you look at the main diagonal, the correlation value is always equal to 1. This is because every variable is perfectly positively correlated with itself. You can see the positive correlation between age and insurance charges, it's 0.299, and the other pairs of variables are only very slightly positively correlated. But this is a correlation matrix. What if you want to visualize this using some kind of chart? ChatGPT to the rescue. I have the correlation matrix for my data in a variable core. How can I visualize this? And ChatGPT immediately suggests a heat map. The heat map that ChatGPT suggests is a Seaborn heat map. On line 4, notice the call to sns.heatmap to use a heat map to display the correlation matrix. The correlation matrix is an input argument, and not equal to true will annotate the heat map. And here is what the heat map looks like. Let me just adjust the figure size of the heat map so we can view the entire display within a single screen. And here is our heat map. A heat map is just a matrix representation with colored cells, where the color of the cells have meaning. Notice that we have the variables along the columns of the matrix and along the rows of the matrix. For example, the correlation coefficient between insurance charges and BMI values is 0.2. Now, the color of the matrix cell represents the strength of the correlation. Stronger the correlation, that is more positive the correlation coefficient, you can see the hue of the cell is more orangish or reddish. Weaker the correlation, lower the correlation coefficient number, the hue of the cell is bluish. As you can see, a heat map is a very nice visual representation of the correlation matrix. So you don't just have to look at numbers, you can also use colors to distinguish correlation coefficient values. You have now reached the end of this course, combining and visualizing data using generative AI, and indeed the end of this learning path on prompt engineering for data science and visualization. We started by exploring how we could combine data. This involved vertically stacking the rows of two or more data frames, one on top of the other. Assuming all of the data frames have the same schema, this operation should work seamlessly using pd.concat, and we saw that for the most part it did. We noted that the order of the columns in the data frames did not really matter. However, if the columns have differing names, then the concatenation does not work as expected and may need additional processing. After that, we perform joins on our data frames using the pd.merge function. Joins are a SQL construct in which two or more tables are horizontally merged together on a common column. With the help of generative AI tools, we performed inner joins. These we saw are the simplest and most widely used kinds of joins. Only the records from both tables that have a corresponding row in the other table are included in the output. We also explored the other kinds of joins, left, right, and the full outer join. Next, we performed time series analysis and visualization. Time series data is data that shows a value such as a stock price or supermarket sales over a period of time at specific evenly spaced intervals. We read in stock price data into our data frame, converted the date column to be of type date time, and visualized the stock price at daily intervals using line charts, all with ChatGPT's help. We then used the pandas grouper object to access the stock price data at weekly and monthly rather than daily intervals. This was useful because if your data is too granular, the chart may have too much noise to extract insights about trends and other factors. Finally, we explored data visualizations in Python. We started by constructing univariate visualizations that display information about just one variable. We then visualized data using bivariate visuals that allowed us to see the relationship between two variables. We used ChatGPT and Bard prompts to explain the relationship that we wanted to visualize and took its suggestions about the chart to use, and also used the code that it generated for these visuals. To round off this course, we also created visualizations using Plotly, a library that specializes in highly interactive charts. In conclusion, you've completed this learning path on prompt engineering for data science and visualization in Python. This knowledge is crucial in all fields in the real world, be it sales, engineering, or even pharmaceuticals. You're now fully ready to leverage your knowledge of data analysis and your knowledge of how to use generative AI to make your life easier while coding.